Hey guys, welcome back to my channel. So I'm sure you've seen these headlines about the asteroid 2024 YR4 and its potential impact with Earth in 2032. Apparently they're bringing in the James Webb Space Telescope to help. The odds of an impact keep going up. I'm seeing thumbnails like this. So though it may seem silly, I think it's time to unpack this latest killer asteroid headline and see what is really going on, as much as we know thus far, and determine if there is any real danger, or is this all just much ado about nothing? You know, like the internet does. So as I said, the asteroid designated 2024 YR4 was discovered in 2024 and is projected to make a very close approach to Earth on December 22nd, 2032. Asteroid hunter David Rankin first pre-covered, which is short for pre-discovery recovery, this asteroid from data in the Catalina Sky Survey. And this basically means he was able to find images of the space rock in archival data that was gathered prior to its official discovery. Though it currently is about 27 million miles away from us, according to NASA's Center of Neo Studies, it's estimated to come within around 66,000 miles of Earth on that December day. However, when orbital uncertainties are considered, that close approach could turn out to be a direct hit on our planet. And in January 2025, headlines started being made when the odds of such an impact that started to be dropped were 1 in 83. And in early February 2025, those odds jumped to 1 in 43. Now, obviously, an asteroid about 200 feet wide smashing into Earth is not the dream. Such an impact could cause an explosion in the atmosphere called an airburst, or cause an impact crater when it slams into the ground. This was enough to see asteroid 2024 YR4 leap to the top of ESA's NEO Impact Risk List and NASA's Century Risk Table. The asteroid is rated 3 on the Torino Risk Scale, which indicates a close encounter that warrants close attention from astronomers and an over 1% chance of impact. Space.com reached out to David Rankin to ask him why the odds of this asteroid impacting Earth have now changed. And he pointed out that we should just look at the math of this thing first. A 1 in 83 chance of an impact represents a 1.2% chance of an impact. That means that there is a 98.8% chance that 2024 YR4 would miss Earth. The new figure of 1 in 43 represents a 2.3% chance of a strike. Rankin points out that means we are still at 97.7% chance of a miss from this asteroid. Rankin explained with newly discovered asteroids like this one, certain characteristics of their orbit are initially confirmed to a much higher degree than others. He said, we end up with a good understanding of the plane in space that the asteroid is orbiting on, but not exactly where along the plane it will be. This manifests with uncertainty along a confined line called a line of variation. For 2024 YR4, the center of that distribution passes close to the Earth. So with every update, Rankin said the uncertainty changes, and this has the effect of slightly increasing the odds that it will hit the Earth, even though the most likely outcome remains a miss. Now, if all of this doesn't make a lot of sense to you, here's an analogy that Rankin used that really helped me. He said, imagine that you're holding a stick that is a few feet long. I should get a stick. Okay, here's my stick. I just stole this from my orchid plant. So it's a little dirty, but imagine that you're holding a stick. He said if you move the stick in your hand like a fraction of an inch, you can barely notice any movement on the other side. Now imagine the stick is millions of miles long, say 27 million miles long. Now moving your hand just a fraction of an inch causes dramatic changes on the other end. Rankin explained that in the case of this asteroid, the fraction of an inch movement is the tiny uncertainties in the positional measurements of the asteroid from the telescope's images that can arise from small timing errors and minor positional errors. He said it's not possible to get a perfect measurement of the the asteroid from any telescope. So all we can do then is plot all of the possible orbits that fit the given observational arc at any time. This ends up producing a normal distribution of orbits that are all possible. Rankin and his colleagues will continue to monitor this space rock throughout February 2025 with 8-meter telescopes at the Catalina Sky Survey. Additionally, teams of scientists around the globe are scanning archival data from 2016, the last time that the asteroid was visible to us. Rankin says if one of them finds it, it will either rule in or rule out an impact in 2032. Failing this, and even after February 2025, and we still don't have a clear idea of whether or not the asteroid will impact Earth, we should be able to better know in 2028, the next time that the asteroid will be visible to us again. Now let's assume that the data we have on asteroid 2024 YR4 is correct. What are we talking about here? What kind of risk does this specific asteroid pose towards Earth? Rankin said that it's likely to be around the same size as the 1908 Tunguska rock. So while impact effects would be more localized than regional, it certainly has potential to do a lot of damage to the area that it hits. Tunguska is currently the largest recorded asteroid strike event in human history, though we know of many greater impacts in prehistoric times. The Tunguska effect occurred in Siberia in 1908, and the explosion destroyed 830 square miles of forest. And apparently a lot of reindeer. Yeah. But the most notable asteroid impact is probably the catastrophic Chicxulub impact, which happened around 66 million years ago and wiped out 2/3 of life on Earth and ended the reign of the dinosaurs. Now that asteroid was thought to be about 6 miles wide. Our asteroid is a lot smaller, but Rankin said that composition of the asteroid could be a huge factor in terms of the damage it could cause. He said if it's made of a stony material, it could cause a significant airburst and fireball that could reach to the ground. He said if it's made of iron, it will punch right through the atmosphere with little trouble and make an impact crater. So this is why understanding not just the orbit, but composition and size are so critical. But thankfully for all of us, Rankin is committed to keeping an eye on this asteroid. He said we will have the opportunity to continue to track this rock through February with 8-meter class telescopes, which we plan on doing at the Catalina Sky Survey. It is possible that even after February, we will not know for sure if it will hit or miss in 2032, but we should be able to determine that better by 2028, when it should be visible again. So I'll see you guys in 2028 for the update. I mean, obviously, there's a lot more information that they need. I get it. We got some data. The data is ever evolving. We have images of asteroids smashing into Earth from the movies and history swirling around in our head. But there's a lot we don't know. So I feel like this story is just one of those very kind of annoying, but yet very adult wait and sees. I think his analogy with the stick is a good one. I mean, a lot can happen to an asteroid in space in 7 years. So as fun, I don't even know if fun is the right word, but as fun, I guess, as all these headlines and thumbnails are, I guess right now it all seems a bit premature for me. But what do you guys think? Is this the kind of story that keeps you up at night? Or does 7 years just kind of seem like too long to really worry about anything? Or do we feel like we've just been down this killer asteroid route before? I think we have. But let me know what you guys think in the comments below. Okay, that's it for now. Thank you so much for watching, and as always, I will see you in the next video.